Steel design is a branch of structural engineering that focuses on designing safe and efficient structures using steel as the main material. It involves calculating the strength and behavior of different steel components such as beams, columns, truss, and connections to ensure they can carry loads like their own weight, people, weight, and other force. Engineers like suitable steel selection, check tension and compression capacity, analyze bending, and ensure connection like bolts and wires are strong enough. Steel design also require following engineering codes and standards such as Euro code or AISZ to guarantee safety, stability, and durability in real-world construction. Steel design is a branch of structural engineering that focuses on design buildings, bridge, and other structures using steel as the main material.
There is two types of restraining conditioning of beam. First one is restrained beams, and the next one is unrestrained beam. Now I explain about the restrained beam. Restrained beam is a beam whose compression flange is fully prevented from moving sideways or rotating. Because of this restraint, the beam can only undergo vertical deflection when it is loaded. There is no lateral displacement and no twisting along the beam. The diagram shows how the beam behaves. From the plan view, which is the top view, the beam is supported between two columns with no sideways movement allowed. From the front view, when the load is applied, the beam bends downward, showing vertical displacement. Section A to A, the post-deflection check indicates that the beam moves vertically but remains aligned sideways, demonstrating zero lateral displacement and zero rotation. This restraining condition increases the beam's stability by preventing lateral torsional buckling.
Unrestrained beam. An unrestrained beam is a beam whose compression flange is not preventing from moving sideways or rotating because its lateral support the beam to vulnerable to lateral torsional buckling when loaded. This type of beam experiences three types of displacement. First, vertical displacement, bending, downward horizontal displacement, sideways movement, torsional displacement, twisting of the cross-section, and the diagram illustrates this behavior. Then Q, the beam bends downward and also shifts sideways, showing both vertical and horizontal movement. For front view, the beam deflects vertically as usually under load. Section A to A. After loading, the cross-section shows lateral shift and rotation governing vertical displacement plus lateral displacement and torsional rotation. This condition reduces beam stability and increases the risk of lateral torsional buckling.
We move to restraining system to prevent flexural torsional buckling in beam. This figure illustrates different structural systems used to restrain beams and prevent flexural torsional buckling, which is a failure mode caused by combined bending, lateral movement, and twisting. Each system provides support to the critical plank C, either continuously or at specific point. For the first one is continuous restraint. This system provides uninterrupted support along the length of the beam, preventing both lateral movement and twisting. For example, include the slab or decking places directly on the compression plank. Number two, the lateral and torsional strength. This configuration use bracing members such as diagonal braces, cross bracing, or stirrup pin to restrain the plank from moving sideways to limit twisting. The system stabilizes the beam by connecting it to stiffer adjacent members. Number three, lateral only restraints. Some systems provide only lateral support without preventing torsion. That's typical involve bracing and placed directly at the compression plank to stop sideways displacement but allows some rotation. Now the last one is conclusion. In conclusion, understanding the restraining condition of beam is essential for ensuring structural stability and safety. Restrained beams provide a better resistance by limiting lateral movement and torsion, while the restrained beams are more susceptible to lateral torsional buckling. By applying proper restraining system such as continuous support, lateral braces, and torsional restraint, engineer can significantly improve beam performance and prevent structural failure. That's all from us. Thank you.